So the test here. 2A, okay, the first test in chapter 2, class 10 science. Now you will be taking this after completing question number 1 to 16, okay, on your tuition note. Okay, on your tuition note. I find this from pages 33 to 41. Pages 33 to 41. So you go through this portion and find some answers there. First question here at the top half, question number 1, 2, 3, 4. You do this only after going through question number 1 to 16, okay? And then the lower part there, the table is given question number 1, fill in the boxes. That also you try to fill it up, make your own on your copy and try to fill them up after going through question number 1 to 16 on the tuition note that you have with you, okay? Now what we're going to do here on the board is your question number 2. Write the balance chemical equations for the following reactions. 7 of them, I think. So A. There, question number 2A. Write down on your tuition copy. Keep your question paper 2A in front of you, and then maybe you can go to 2A. So number 1, subheading 1. Let me read the question. Reaction of zinc with number 1, dilute sulfuric acid. So you write here number 1, zinc, a little bit below, and put a plus sign here. And zinc means we know Zn, Z, capital Z and small n. Okay, the first and the third letter of the word zinc is the symbol for zinc. When we write like this, we know it's zinc ion. But when the question is saying zinc, it's this. There should be no plus or minus charges. Zinc with sulfuric acid. So you write here after this, sulfuric acid. Now you know worksheet 1 double plus. Formula for sulfuric acid is H2SO4 if you want AQ. Even if you forgot to put that symbol for aqueous, that's fine, okay. What reaction would come out? Now go to page 47 of your textbook and see whether this zinc is above hydrogen or not. Is this zinc above hydrogen or not? Check. I think it's page 47. There's a table there. Green table right at the bottom there. Zn is above hydrogen, means Zn is more reactive than hydrogen atom. So you can easily push out this hydrogen gas and it will come out as hydrogen gas. So you write your hydrogen. It will appear as gas bubbles, okay, invisible gas bubbles appearing in your test tube when you put zinc metal is solid and you put this sulfuric acid. Then you will see some gas bubbles coming out, which is this hydrogen. So this is possible because zinc is more reactive than hydrogen, so it will replace, okay, or displace rather hydrogen and come out, and then zinc will take the place of H2. So when you put Zn here, what would you get? Zn, and then this part just write as it is without thinking so much about whether that is correct or not, okay. So then you remember your starter and try to correct. Zinc is always, no need to write this, okay, Zn2 plus, and we know SO4 sulfate is always 2 minus, so these 2 cancel. So the formula will turn out to be ZnSO4, so which is already correct, so nothing to correct. So you check the correctness of the formula after you write the symbol only, and if it's correct, keep it like that. And now you write the name, zinc, you know, zinc ion, first part, so zinc, and then sulfate ion. So for that we write sulfate, so the compound is zinc sulfate, right? Here only 1, so this is an atom, no need to write this. 2 atoms of hydrogen, 1 sulfur atom, 4 oxygen atoms, so 4 plus 1, 5 plus 2. 7 atoms are making sulfuric acid, so definitely this is a molecule. 2, more than 1 is a molecule. 1 atom, 2 means 1 zinc atom, 1 sulfur atom, so 2 atoms together. 2 plus 4, 6 molecule. Before that, let's check balance in Zn, H2, S1, O4, O4. This is already balanced. So let's read the balance equation once. One atom of zinc reacts with one molecule of sulfuric acid to give one molecule of hydrogen and one molecule of zinc sulfate. Okay, or you can also read it as zinc on reaction with sulfuric acid, zinc displaces hydrogen from sulfuric acid to give hydrogen and zinc sulfate. Okay, so this is the method by which hydrogen gas can be manufactured or produced. So second one, number 2. Look into your question paper. Reaction, the top A, reaction of zinc with number 2 dilutes hydrochloric acid. So zinc now reacts here plus with dilute hydrochloric acid. As we know, the symbol for zinc is the first and the third letters, Z capital small n. If you want, you can mention it is solid. But even if you forgot to put these symbols for solid, aqueous, liquid, gas and all, it's not so strict. If you want, you can put here is AQ. It will come out in the aqueous form, means in the form in which it is dissolved in water. If you want. Otherwise, those are not so strict. Now you see here. Hydrogen chloride is H1 plus. Don't write, okay? Chloride Cl1 minus. So this is the formula for hydrogen chloride gas. Now when this hydrogen chloride gas is dissolved in water, distilled water, pure water, that is called hydrochloric acid. So hydrochloric acid is denoted usually by HCl-AQ, meaning hydrogen chloride gas, dissolved in water is the hydrochloric acid. The dry gas hydrogen chloride is mentioned as the gas is this. The acid is this. Hydrochloric acid means dissolved hydrogen chloride, same compound, but dissolved in water. So when it reacts like this, you can go to page number 47 and see activity series, page 47, green table at the bottom. As I said, zinc is again above hydrogen, so it will easily displace this hydrogen and produce hydrogen gas. And we know the hydrogen formula is always H2, so you write that down. Plus, then zinc will take this place. So if zinc push out hydrogen and it take its place, what will it turn out to be? Zn, and then just write the symbols without thinking too much. What should be the number? Don't think about the correctness of the formula in the initial stage, okay? Then you will take your starter. We know that zinc is always associated with the ion Zn2 plus, chloride is always Cl1 minus. So the formula will turn out to be 1 go down, no need to write, 2 at the back of Cl. So 2 should be here. So correct the formula after you write the symbols. So that's the correct formula for zinc chloride. Then you write the name below it, zinc chloride. So this is the skeletal equation. So we need to check it for whether it's balanced or not. Balanced means number of each atoms, means on the left should be equal to number of atoms on the right, meaning number of zinc atoms on the left should be equal to number of zinc atoms on the right. Likewise, for every atom on the left should be equal to the same atom numbers should be equal on the right. So at the back no number, so 1, zinc 1 atom, here also 1. So far balanced. Now go to the next. H is 1 here 2. So that cannot be. So to make it equal, we have to obviously increase the smaller one 1 to 2. Cannot balance from back, we're not allowed. So 2 hydrogen atoms on the left and 2 hydrogen atoms on the right. So hydrogen is balanced. The moment you do that, 2 ones are 2, this 2 will belong to both. So 2 chlorine atoms on the left, 2 chlorine atoms on the right. So hydrogen also, chlorine also balanced. We need to go back to zinc and check. Zn 1, here also 1 zinc atom, 2 hydrogen atom, 2 hydrogen atom, 2 chlorine atom, 2 chlorine atoms. So equation is balanced. Nonetheless, determine which are atoms and which are molecule. At the back, here no number means only one atom, so it is atom. While determining whether it's a compound, it's a molecule or an atom, don't look at the front numbers, only the back, okay? So here back 1, here 1, so 1 plus 1. 1 hydrogen atom and 1 chlorine atom makes hydrochloric acid. So 2 atoms means more than 1 atom, so it's a molecule. Here 2, so molecule, more than 1. 1 zinc atom. 2 chlorine atoms means together 3 atoms, so more than 1, so molecule. So now we can read the equation. 1 atom of zinc reacts with 2 molecules of hydrochloric acid to give you 1, no number in front means 1. 1 molecule of hydrogen gas or hydrogen and 1 molecule of zinc chloride. That's how the balanced equation will read. So let us go to the third one. Question number A, subheading 3. Start from the beginning at the top. The reaction of zinc with 3 acetic acid. So zinc again, you write, and we know the symbol for zinc is Zn. If you want, solid. Then it reacts with acetic acid. So write the formula, acetic acid. And we know acetic acid formula is CH3, COOH, aqueous, because acids are usually dissolved in water. That is not so strict anyway, but if we can write it, it's good. Now go and check whether Zn is above hydrogen again or not. This is not the replaceable one, this is the one, okay? And you will see there, page 47, we have seen it 3 times now. Zinc is always above hydrogen, so it will replace this hydrogen and produce the hydrogen gas. So write that down. And then it will take its place. So you write here, this compound is slightly different. See here, CH3, COO is left. H is gone out here. Then Zn will go and take this place. So just write that Zn. Don't think about whether it's correct or not. Then you remember your starter and you will know that CH3, COOH is 1 minus. Zn is always 2 plus. So here 2 and 1 can't cancel. 2 will go to the lower backside of this one. So the formula will turn out to be this one here. 2 will go to the lower backside of this one, meaning more than 1 atom, so compound ion 1, 3, 5, 4, 5, 6, 7 atoms. So it's a compound ion, so we need to put bracket because the number we are going to bring down is greater than 1. So after that you put this, bring to the lower backside of this one, it's 2 at the top of zinc and 1 need not be shifted. So the correct formula is this one and then 2. Then we can name it now. So here, this one is I want to explain one thing here. Usually in writing compound, Zn2 plus Cl minus. So positive radical is in the left front and negative radical is on the right second place. First place usually positive, second place negative. But here CH3CO minus is negative, Zn plus is on the right. This is unlike the rest. So it's an exception. Usually compounds are written with positive in front, Zn2 plus Cl minus, but here negative in front, CH3CO minus, Zn2 plus. This is the correct way, okay? But this is the only case, or let us say an exception, okay? So we have to name the positive first. Writing is always zinc chloride, positive is written first, zinc ion Zn2 plus. So we have to, even though the Zn is at the back, written as an exception like that at the back, we have to write the name like normal. Positive part name first zinc, and then here acetate. We know that on your starter this is acetate ion, so zinc acetate. Once we're through, let us balance the equation. Zn 1 atoms on the left, on the right 1 atom. Carbon 1 and 2. Here also 1 and 2 inside, so 2 and outside bracket 2, so 2 here 2, so 2 2s are 4 carbon atoms on right. So that cannot be, so we put here 2. Let us say, okay. So we put that 2 then here. Don't count this now inside 1, 2. So 2 2s are 4 carbon atoms on left. 1, 2, 2 2s are 4. Balance. After carbon, let us go to hydrogen. 3, don't count this one inside first. 3 plus 1, 4 hydrogen atoms. So 4 multiplied to 2 because 2 belongs to everything. 4 2s are 8 hydrogen atoms on the left. And then on the right side, 3 here. So 3 2s are 6. And here 1, 2 more. So 8 hydrogen atoms on the right side. Here also 3 plus 1, 4 2s are 8 hydrogen atoms on the left. So carbon balanced, hydrogen balanced. Let's check one final time. Zinc 1 atom. Here 1 atom. Carbon 1, 2. So 2 2s are 4 carbon atoms on the left. Here also inside 1, 2 carbon atoms. So 2 2s are 4 carbon atoms on the right. 4 carbon atoms on left and 4 carbon atoms on right, so balance. Hydrogen, 3 plus 1, 4. 4 2s are 8 hydrogen atoms on the left. Likewise, 3 2s are 6 hydrogen atoms here, plus 2, 8 hydrogen atoms on the right, so it's balanced. Here at the back one, so this is atom. Here more than one atoms. While determining whether it's a compound, it's a molecule or a atom, don't look at the front one. Back here, 1, 3, 4, 5, 6, 7. So more than one molecule. More than one molecule. Here also definitely more than one, so molecule. So let us read the balance equation. One atom of zinc reacts with 2 molecules of acetic acid to give us 1 molecule of hydrogen and 1 molecule of zinc acetate. Okay, I hope you're getting. And let's go to the fourth one. Right. So here, the fourth one. Question number 2A, subheading 4. Look into your question paper. Go back to the top reaction of zinc with and go down for sodium hydroxide. So this time zinc is reacting with sodium, a little bit below the plus, you write sodium hydroxide. So if you want, you can mention zinc is always solid. If you forgot also, that's not so strict. Now let's write the formula by remembering the starter, sodium hydroxide. Sodium ion, Na1 plus, don't write that, hydroxide, OH1 minus. So the formula of sodium hydroxide is NaOH. It's usually taken in the aqueous form, so if you want to mention that. Now you see here, it will react, and then this one you just remember, okay, on the right, it will produce a compound called sodium zincate. A little bit below the arrow, so write the name. Just keep that in your mind, that when these two react, always sodium zincate is produced, and the other product is always hydrogen. Hydrogen, though we know, H2 gas. Now let's write this formula by remembering our starter. Zinc, sodium ion, is Na1 plus. Zincate ion we know is from our starter, ZnO2, 2 minus. So here 2 minus, here 2, 1 plus, so 2 and 1 can cancel. 1 at the top of Na can be brought to lower backside of ZnO2, but we know we don't write for 1, right? So go to 2 and bring it down to the backside of Na. So the 2 at the top of ZnO2 will come to the lower backside of sodium, and that is called sodium zincate. Let us balance now. Here you see Zn1, here also 1. Na1, here 2, so we need to put here 2 to increase it to 2 to balance this 2 on the right. Now next, 2 oxygen atom, here also 2. 2 ones are 2 hydrogen atom, here also 2 hydrogen atoms. So zinc atom on the left, 1, on right also. Don't look at this number, this belongs to Na, this belongs to O. For zinc at the back of Z, no number means 1, so 1 zinc atom, right side, left also 1 atom. 2 sodium atom on left side, at the back of NaC, 2 sodium atoms on right. 2 ones are 2 oxygen atoms on left, 2 oxygen atoms on right. 2 ones are 2 hydrogen atoms on left, and clearly 2 hydrogen atoms on the right. At the back 1, so this is atom. Here 1, 2, 3, so more than 1 is molecule. 2, 3, 4, 5, so more than 1 molecule. 2, more than 1, so molecule. Let us read the balance equation. 1 atom of zinc reacts with 2 molecules of sodium hydroxide in the aqueous form usually to give us 1 molecule of sodium zincate and 1 molecule of hydrogen. Okay, so once we're through, let's go to the next one. 4 and 5. 4, finished. Now we'll go to the next question. Question number 2B. Okay, 2B is sodium carbonate reacts with dilute. So sodium carbonate, you write down. Sodium, the first word that you get. Remember the starter and write the formula. Na1 plus and carbonate ion is CO3 2 minus. So here 1 and 2 can cancel. So 2 at the top of CO3 will go to the lower backside of. And so sodium carbonate formula is Na2CO3. Reacts with dilute hydrochloric acid. So you write here plus dilute hydrochloric acid. And we know hydrochloric acid is hydrogen chloride dissolved in water, AQ. So when they react to give sodium chloride, so it's given in the question itself, so right there, a little bit below the arrow, sodium chloride. At the top you write Na1 plus, and chloride ion we know is Cl1 minus, so 1 and 1. So that's it, that is the formula for sodium chloride. Water and carbon dioxide. So you get your next water and carbon dioxide finally. So write down a little bit below the plus, carbon dioxide, and write your formula for carbon dioxide. Very easy. So this is the skeletal equation. Now let us try to balance them. Here Na2, only 1, so we have to make here 2 in front. We cannot balance from back. 1 carbon atom. This C is not carbon, this is Cl, chlorine atom. Here, carbon atom 1 on the left. This is not carbon, chlorine. Go here, 1 carbon atom on the right, balanced. Oxygen 3, 2 plus 1, 3, so far balanced. Go to H, 1 here, and here 2. So we need to make this one 2. Right, so 2 hydrogen atoms on the left, 2 hydrogen atoms on the right. And 2 chlorine atoms, 2 ones are 2, 2 ones are 2 on the left. So it's balanced, I think, now. So molecule, 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 molecule. You can clearly see everything is molecule. So let's read it out, the balance equation. 1 molecule of sodium carbonate reacts with 2 molecules of hydrochloric acid to give us 2 molecules of sodium chloride, 1 molecule of water, and 1 molecule of carbon dioxide gas. Okay. 2 more questions, C and D. So 2C. Let's go to C. 2C. Let me read the question. Sodium bicarbonate. So let me write that down. Sodium bi. Now let's write the formula for sodium bicarbonate by remembering the starter. Sodium ion is Na1 plus. Bicarbonate ion, you know, is HCO3 1 minus, so 1 and 1. So this is the formula for sodium bicarbonate, NaH CO3. Then react with dilute hydrochloric acid, so plus, below that you write dilute hydrochloric acid, and write the formula for that, HClAQ. Then as you go on, it produces sodium chloride, water, and carbon dioxide, same as previous one. Sodium chloride, write down Na1 plus, Cl1 minus, so this is the formula. Water, H2O, and then finally carbon dioxide, so CO2 gas, if you like. So it's the same product like the 2B, but it's a different compound. On the left, to sodium bicarbonate here, previous one was sodium carbonate. So when sodium carbonate or sodium bicarbonate reacts with dilute hydrochloric acid, the products are the same. Okay, but the balancing we have to check. Na1 here also 1, H 1 plus 1 2, 2. Carbon on the left 1, this is not carbon, chlorine, carbon, here also 1. Oxygen is 3, then here also 2 plus 1 3. Hydrogen is done, chlorine is 1, here also 1. So I think that is nothing to balance, this already balanced. The last equation to balance, 2D, okay, and let's go there. So 2D is, let me read the question, reaction of carbon dioxide. So you write here, carbon dioxide, one of the reactants, CO2, usually gas, react with lime water. Lime water, so you write your lime water. Lime water is actually common name, okay? So the real name is, lime water means chemically its name is calcium hydroxide, so you can write that also. And you use this calcium hydroxide to write the formula, because we cannot write the formula from the common name. So calcium ion is Ca2 plus, hydroxide is OH1 minus. 2 here, 1 need not be shifted, 2 go to lower backside of OH. Only after a bracket, because there are 2 atoms, meaning a compound ion. calcium hydroxide to give you calcium carbonate and water. So calcium products are calcium carbonate, Ca1 plus, carbonate ion is CO3, sorry, calcium ion is Ca2 plus, calcium carbonate also CO3 2 minus, so 2 cancel. So that's it. And usually calcium carbonate is solid, okay. So okay, lime water is usually dissolved in water. It's okay, but if you can mention dissolved in water means aqueous, and the arrow can be pointed clearly. Solid. And then water, the other product is water here, so which is H2O. Then next, let's check for balancing. One carbon atom on the left. This C is not carbon, this is calcium Ca. One carbon atom on the left. This is not the carbon, this is the one on the right. So balance O2, and here bracket, so 2 ones are 2O plus 2 4O. Here 3O 1O 4O, 3 plus 1, so balanced. O is done. Now calcium atom on the left, 1, on the right also 1 atom. Oxygen is done, hydrogen, 2 ones are 2 hydrogen. Here also 2 hydrogen. So this is a balance equation. We can clearly see all our molecule, because more than 1 atoms clearly we can see. So let us read the balance equation. 1 molecule of carbon dioxide react with 1 molecule of lime water or calcium hydroxide, the real name, to give us 1 molecule of calcium carbonate. It is whitish in color, okay, and then water, 1 molecule of water. That concludes. There's question number 3 there. Fill in the blanks. Dash turns blue litmus paper to red. Try to answer this by searching, by reading question number 1 to 16. I repeat once more. Then the first half of the question number 1, 2, 3, 4. You try to write their answers after reading the question. You can search for the answers and make your own answers. Then down there, the table, fill in the boxes also. You try to fill in those boxes by making those boxes also on your tuition copy, and fill in those boxes by searching for their answers from question 1 to 16. And last question number 3 also. What turns blue litmus to red? You'll find them, search the answer from question 1 to 16. The rest that I have practiced with you is question number 2. All these 4, 5, 6, 7 chemical equations. After you're ready with all of this, then you take the test. I hope that's fine, right? Okay.